Hi, I'm Allison Crocker, and welcome to these faculty office hours. I teach in physics.
Hi, I'm Mary James. Again, welcome to all of you to Faculty Office Hours. I'm also teaching the physics department, and for the last few years, I've been serving as the Dean for Institutional Diversity. What I try to do is not figure out what dark matter is, but where it is. One thing we do know about dark matter is it does not interact through the electromagnetic force. So we have to find some way of using signals from photons coming from space to sense the presence of dark matter. And one of those strategies is called gravitational lensing. And that basically means we measure the bending of photons as it passes through dense clusters of dark matter.
As I said, I'm an astrophysicist, and I am an observational astrophysicist. In much of the physics world, there's this divide between like theory and experiment. But I can't do experiments because I can't go out and poke my galaxies. So mine, it's sort of experimental-like, but it's actually observational. So the studies are designed a little bit different, but I use data from telescopes all over the world and in space to study how relatively nearby galaxies are forming stars or not forming stars, depending on the properties of the galaxy. I was just going to mention a few people. So Mark Beck is an experimental quantum optics person. So he has a ginormous quantum optics table in the basement and studies, first entangles pairs of photons, which him being in the department, I've learned is a tough thing to do, and then does experiments with them because it's really fun. You sort of do these experiments that really show that quantum mechanics is a thing, that you entangle these particles in a way that would mean if it wasn't quantum mechanics that we have something traveling faster than light. And so that's really happening in the Reed physics department basement. And another person, I wanted to mention someone on the theory side, Joel Franklin, is really sort of a mathematical physicist and loves thinking about the theory of general relativity, which tells us what Mary was talking about how mass bends space-time, and so has studied a lot of neat little nuggets in the theory of general relativity and sort of coupling it with electromagnetism.
Another thing I just want to say about the department is we're really interested in our students working collaboratively and supporting one another. So we're not interested in pitting you against each other in any sense. We want you to grow and learn physics in a really supportive environment. And so we do everything we can to encourage students right from the beginning.
We bring in speakers from outside Reed, and occasionally within Reed, we give talks to present their research. And so just the way Mary and I have given you the shortest of snippets about what our research is about, we bring in people who have their own research programs that are totally different than the 8 faculty members in the physics department. So that's a really fun weekly event. And students get free lunch and get to go to lunch with the speaker. And so particularly if someone's in a subfield that you're really interested in, it is a great idea to go out to lunch with them. They're really friendly people, and they tell you what their path was like to be a researcher in that subfield. And you hear a little bit more about their work. And then another thing that we do is the sophomores go bowling with the faculty and staff every fall, just to so we all get to know each other, as people in their sophomore fall are generally pretty sure they're going to be physics majors, although you can still be deciding sort of up through your sophomore spring. And then a little thing that we do, but I'm very involved in, is I have sort of an astrophysics journal club that's very informal, meets once a week for about a half hour just to talk over a new paper in astrophysics. Reed faculty in the physics department hire students every summer to work on their own research projects. So I'm going to be working with 3 different students this summer on really 2 different projects. 2 students are going to work on the same project. And the same is true for, I think, 3 other faculty members. So we'll have a cohort of 8 to 10 students working on research over the summers.
Physics theses take many, many forms. There are experimental theses, there are observational astrophysics theses, there are computational theses, and there are theoretical theses. And many theses have some combination of all of those. So some of the most wonderful projects I've worked on over the years involve an experimental component, a computational component, and a theoretical component. So the thesis project is the culmination of your Reed physics education. One thing I think is really important, and it's a full year research project directed by one of the faculty members. Really, it's a project of your own choosing with lots of guidance from the physics faculty, and a project where you're really going to explore something, certainly that a lot of things that you as an investigator don't know yet. An important thing to know at this point, we don't expect you to be ready to do a thesis when you get here in the fall. So you have 3 years of preparation before you embark on the thesis, and then you'll be guided through the project by a faculty member.
So I have 2 students who are really working within astrophysics on things pretty related to what I work on. One studying how star formation is suppressed in the center of a galaxy by studying signs that the gas there is turbulent. And another is studying the gas dynamics, so how the gas is being flung around due to a recent merger between 2 galaxies and what that means for maybe the fate of the gas in that galaxy. So those are projects sort of in my own wheelhouse. And then I have another student, and they're studying and it's an experimental thesis studying the dynamics of like an avalanche of granular materials. So as a student who's interested in avalanches is like someone who goes skiing and doesn't want to be caught in an avalanche. And for their senior thesis, they just wanted to know like how barriers that you might place in an avalanche's way work.